Okay, I hope my audio is working. Version 4.0 of the TSN magnetometer. I've had brain fog, and I've heard this from a lot of people, and I think it's from solar flares and geomagnetic activity. But after a lot of thought and sick of seeing these graphs in the resolution that I don't want to see them in, this is the plotting mode that if you've viewed our data, that you're most accustomed to seeing. If I sound tired, I've been coding for 2 days. This is how we usually, for a year now, have seen our data. Yeah, you can see the changes, but they're minute, and I'm zoomed in with my mouse zoom. So you got your y-axis, z, x-axis,
transient detected,
b total, and your heading. And that's wonderful. It's I've now called this a scaled plot. You got 2 zoom modes. Then you got a real-time plot that'll go out and get it as fast as it can get it. And by the way, we are in a state of geomagnetic instability right now. Now we have nanotesla scale plotting. So I'll just let this plot for a while. These are changes on the orders of nanoteslas, the scale ranges. It gets a reference value, and for the next 15 minutes until the plot resets, it's based on that reference value, which is 30,321 nanoteslas total field, or in microteslas that's 30.1. It's rounding it off to 30 microteslas. But now we're down to nanotesla scale. This is what I've been waiting for. So along the time tickers here, any plot along that is a 0 deviation from when the plot started, and I will get the values in here. I just
transient detected,
literally just got this working. So anything along this line is 0 variation in either direction, and it goes from this is 1,000, negative 1,000 nanoteslas. Right now I've got it. I will put a zoom mode in later. I think this is zoomed in a little too much. I'll probably zoom out to minus 1,000 to plus 1,000 deviation.
transient detected.
Right now I've got it set to the very bottom of each section. This would be minus 2,000 nanotesla variation, plus 2,000 nanotesla variation, and in between, that's what the thousands are for. Plus 1,000, negative 1,000. T is your total field, your z-axis, your y-axis, and your x-axis, and it still picks up the transients. You can see what's going on much better down at this microscopic range. Is to put it in layman's terms, this is 1,000 times magnitude zoom level than we had previously. It's moving the decimal place 3 points. That's the amount of resolution, and I'm getting this out of a Honeywell HMC583L magnetometer sensor and a Arduino. We are in beta testing phase, and there's 2 other units, one in Maine, one in Nevada. They don't have the software and firmware yet, but as soon as I test it for a night or 2, I will be rolling it out to them. And I do want to add, the zoom feature doesn't work in this mode right now, so there's a total of 3 plotting modes. The 2 that you have seen before and this new one. So when I add the zoom mode, I'll probably actually zoom out and make it a variation, plus or minus 1,000 nanoteslas. And right now we're looking at variation of plus or minus 2,000 nanoteslas. And to do, I still need to put the reference value, squeeze that in somewhere, and then have it update probably right here in between on the 0 line. The current reading,
Transient detected.
probably the current reading in real time. Or I may put the, it might be a better idea to put the reference, that would probably be a better idea, on the 0 line, on the 0 deviation. Put the reference, the value that it's in variance to. So like right here, in between these, in between the 1,000 and the negative 1,000, I'll probably put the reference value, which is my total field reference is 30,321 nanoteslas, and at the end of this plot it'll go get a new reference number, whatever the most recent reading is at the time that it resets the plot, and that'll be its new reference. And then it'll continue to detect variations upon that. So right now, whenever it's plotting on the white line, that's a 0 variation. It's at like right now, it's right at 0. It's flirting around minus 300, and I don't have the mouse values mapped out. The time is, if you notice, as I move across, the time is mapped, but for each separate
Transient detected.
For each separate axis, I still have to add the code to map out the values. So, but just wanted to share that. Just literally just now got all the plotting working, and a few things to tidy up, a couple more days of tinkering with it, editing code, and I'll be ready to release version 4.0. I want to let this go to the end just to make sure that my reference does update. So we got 7 minutes left. It is 7.5 minutes in. I'm working on a cheaper, more affordable version. It'll be a smaller unit. These current units have USB and Bluetooth connectivity. I can build them about 40 $30 to $40 cheaper by omitting the USB interface. So I do have plans in the works to have a smaller, more affordable unit that is Bluetooth only. I'm saving components and size of the unit by omitting the USB interface. And I'm also working on a mobile version that I had done a video on last year, but I'm updating it to not only do mobile field plotting with a touchscreen menu, but also have it work as a standalone unit and work with this software over Bluetooth and USB. So the mobile version, while it'll be quite expensive because of all the components involved, I'm guessing somewhere around $189, $199, but it's a complete mobile unit with a 4-inch touchscreen, Bluetooth and USB, data logging to a SD card, and it works with this software. So once the software is complete, I will begin work on the Bluetooth only version and finishing up work on the mobile version. The mobile version does work right now. I don't have it Bluetooth enabled yet, and I don't have all the touchscreen menu features implemented that I want, but that will be coming. So let's see, another 5 minutes, and we'll see if this is a first time test for me. And it has picked up 9 transients so far. And for the record, in the past, some of the transients were false positives. It was from variable overflows, where a floating point or an integer value would exceed its
transient detected.
Would exceed its limit and the number of bytes that it could hold, and it would roll over. That has been fixed, and any transients that are picked up now are true transients, whether they are from a geomagnetic storm or from your local environment. Looks like the z-axis is the most active right now. So let's see, 12 minutes. 3 more minutes and we should get a new reference. And I would like to make this a 24-hour plot, but that is going to take a lot more coding, and I don't know if I want to dive into that or not. I could actually write a separate app to do that instead of squeezing it into this app, where you would load the log files that the software generates. Not only does it generate the plots that you see on the internet in our data repositories, but it also exports the averages on each axis over the 15 minutes. So I could write an app that would do a 1-day 24-hour plot and use those 15-minute averages as the data set. So you could plot, say, for a few days, load the log files in, and generate 24-hour plots like this. A lot of ideas, not a lot of time to get it done. Another minute and a half, and if all goes well, we should get a new reference. No matter how large or small, I just want to see the total field reference change. One minute left. As soon as it's done, it'll save, upload this to the internet, get a new reference value for all three, for all X, Y, and Z, calculate B total, and then each segment will have new reference values. About 10 seconds. 4, 3, 2, 1. New plot. And it did update the reference. Now it's 30,526 nanoteslas total field. So that is the new 0 point. And I'll have to play around with the values. I may be zoomed in too much. I may need to scale this down. But we are having a geomagnetic storm, so that may be the reason for the instability. If you want to find out more about what we're doing, www.tsnresearch.com.